Myoglobin and hemoglobin are excellent proteins that help us to understand the third and fourth level of protein structure. Myoglobin is good to explain the tertiary structure of the protein because it's going to contain a sequence of amino acids that are going to make alpha helices. It's also good to explain that it's a conjugated protein because it contains a heme, and I'm going to explain a little bit what is a heme. And it's also good to explain how the hydrophilic amino acids are located on the surface of the protein, while the hydrophobic amino acids are in the core of the protein. When you guys look at pictures, it's good to understand that when we see ribbons, like a coil, that will be an alpha helix. The arrows represent the beta sheets, and sometimes the symbol of the lightning represents a disulfide bond. I want to show you also the actual structure of a protein myoglobin, so you guys can see that you guys have access to that in your textbook and also in my PowerPoint. So what you see in red is what is called the heme. That is the location where oxygen is going to bind. In myoglobin, you will find 8 helices, and only one amino acid is connected to that iron center, to the heme, and that's what is going to be called a proximal histidine. And then you also will have a distal histidine. Myoglobin is excellent about binding oxygen and is found abundant in the muscles. So what we see here is that this is a conjugated protein because it has a heme, and that will be called a prosthetic group because it's part of the function. We are saying that we have hydrophobic amino acids, and why is that? Why do we need to have hydrophobic amino acids? And that has to do with the nature of the heme. The heme is a hydrophobic organic compound with large number of unsaturation, loss of double bonds, and is to protect that the iron doesn't become reduced to iron 3+, so that the binding of oxygen is a reversible reaction. If we look at hemoglobin, hemoglobin is 4 myoglobin-like. With the same function, they will also have 4 iron centers, 4 hemes, but these 4 subunits that are like myoglobin will be making molecular interaction by salt bridges, and that is you will have the amino acid of lysine, for example, making a strong interaction with the carboxylic acid N of another subunit. That will be a salt link, very important for keeping together the unit of hemoglobin. I want to show you the structure of the heme. This is where the iron center that will be bound to the polypeptide by a histidine amino acid on the bottom, and then the top will be open, allowing the access of the molecule of oxygen to bind iron. This is actually the structure that I'm showing you here. Is the structure of hemoglobin. You see 4 different colors. You see a yellow, purple, green, and blue. That is showing you the 4 subunits of hemoglobin. But myoglobin also will have the same. So in both cases, let me just show you the pictures together so we can compare myoglobin and hemoglobin. So you guys see, you guys have access to this. In myoglobin, 1 subunit, 1 iron center. In hemoglobin, you will have 4 subunits, 4 polypeptides, 2 beta chains and 2 alpha chains, and they are going to be in interaction with each other by use of salt bridges or salt link.